Bismillahirrahmanirrahim and Assalamu alaikum. I hope that you all are doing well at your homes in this critical situation. This is week 2 and day 3 of class 9th physics, and today we are going to study about the states of equilibrium. In our previous topic, we discussed about equilibrium and its two conditions, that a body is said to be in equilibrium if there is no net force acting on a body. And there were two conditions of equilibrium. First condition was sum of all the forces is equal to 0, or you can say sigma F is equal to 0. Whereas the second condition was that sum of all the torques acting on a body must be equal to 0, or we can say that sigma tau is equal to 0. If you look into this example here, this is the block that is lying on a table. You can see that the weight of the block is acting in a downward direction, while the reaction of the table is acting in an upward direction. So these both forces will cancel the effect of each other. So the resultant of the forces will be equals to 0. So it satisfies first condition of equilibrium. As you can see that the block is balanced, it means that the clockwise movement is equals to the anti-clockwise movement. So it also satisfies second condition of equilibrium, that is sum of all the torques acting on a body is equals to 0. Moving on to today's topic, that is states of equilibrium. How many states of equilibrium do we have? Yes, we have 3 states of equilibrium: stable equilibrium, unstable equilibrium, and neutral equilibrium. Now let us study about stable equilibrium first. That a body is said to be in stable equilibrium if it comes back to its original position when it is slightly tilted or displaced. Now let's see an example here. This is a book that is lying on a table. As you can see that the book is in equilibrium position. It means that sum of all the forces as well as the torque acting on a body are equals to 0. When I am applying a slightest force or a slightest tilt on the book, and I displace it from the original position and move it here, and I release it, you will see that it will return back to its original position, or it will come back to its original position. So if a body comes back to its original position after a slightest tilt, then this state is known as stable equilibrium. Whereas the red dot in the book represents the center of gravity of the book. Center of gravity is the point where the whole weight of the body appears to be concentrated. When the body was in equilibrium position here, its center of gravity was at the lowest position. But when I applied some force on it, or when I slightly displaced it from its original position, here you can see that the center of gravity arises. I know when I will release it, it will come back to its original position and its center of gravity will again be lower, or we can say it will be stable by lowering its center of gravity. But in stable equilibrium, the body is at the lowest center of gravity. When you slightly tilted it, its center of gravity rises, and it returns to its stable state by lowering its center of gravity again. Let's see an example here. This is a block that is shown in a figure. This is the base of the block. This red point here represents the center of gravity. And this is a line of the center of gravity which is passing from the base of the block. Now the body will remain in stable equilibrium as long as the center of gravity acts through the base of the body. or we can say the body will remain in stable equilibrium, or it will come back to its original position as long as its center of gravity passes through the baseline of the block or of the object. But if the center of gravity does not passes to its base of the block, then it will be unstable. Let's say here it is in equilibrium position. If I am applying a slightest tilt on this block, its center of gravity rises. Now the block returns to its previous position because the center of gravity passes from the base of the block. Now if I am applying further tilt or further force on this block, you can see here the center of gravity does not passes from the base of the block. So in this situation, the body becomes unstable. For this, we understand that firstly, in equilibrium position, the body is at, for the stable equilibrium, the body is at the lowest center of gravity. When we tilt the body in stable equilibrium, its center of gravity rises and it should pass from the base of the object or of the body. And if the center of gravity does not passes from the base of the body, then it means that the body becomes unstable. Now, what does unstable equilibriums mean? We have discussed that in stable equilibrium, the body comes back to its original position after a slightest tilt. But if a body does not come back to its previous position, then the equilibrium is known as the unstable equilibrium. Let's see an example here. You can see that these are the objects which are unstable when the center of gravity lies or fall outside the object's base. This was the base of this object, this was the base of this object, and this was the base of this object. When the center of gravity does not pass from the base of the body, then the body becomes unstable. Why? Because all of the object's weight can be considered as acting through the center of gravity. If this acts outside the base, if it means that if the center of gravity acts outside the base, then it will cause a turning effect or a movement in a body. And if there is a turning effect that is produced in a body, then it does not satisfy this second condition of equilibrium. So the body will not be in a state of equilibrium. It will be unstable. Now let us study about the relation between the center of gravity and stability. We have discussed that if the center of gravity is at the lowest position, it means that the body will be more stable. And if the center of gravity is at the highest position, it means that the body will be unstable. So it means that center of gravity is inversely proportional to the stability of a body. It means that if we want to make the body stable, we have to lower its center of gravity. That is why vehicles are made heavy at its bottom to keep its center of gravity as low as possible. That lower center of gravity keeps it more stable. Now, the base of the vehicles is also made wide. Why does it happen? So that this vertical line that is passing through the center of gravity should not go out from the base. What will happen if it will go out from the base? Obviously, when the line that is passing from the center of gravity to the base, if it will go out from the base, from this base, then it means that the body will be unstable. So that's why the vehicles are made heavy at the bottom, as well as they are also made wide from the bottom. For stable objects, the center of gravity should be at lowest position. If we want to topple over the objects, it means that if we want to unbalance the objects, we need to rise or we need to raise the center of gravity. They are difficult to topple over. For stable objects, it is difficult to topple over. It means that those objects whose center of gravity is at the lowest point, it is very difficult to make them unbalanced. Let's say we have an example of of a square here. If I am slightly tilting this square by applying a force, because its center of gravity is at the lowest position, it will come back to its original position. The block will be stable. Same for this cone and for this cylinder. Next thing we have is unstable equilibrium. In stable equilibrium, we discussed that if a body comes back to its original position after a slightest tilt, then it is known as stable equilibrium. But what happens when it will not come back to its previous position? Then this state of equilibrium is known as unstable equilibrium. So let's study about the definition of unstable equilibrium here. That a body is said to be in unstable equilibrium if it does not come back to its original position when it is slightly displaced or it is slightly tilted. We have an example of a pencil here which is in vertical position. Now when I am slightly tilting this pencil, you will see that it will not return to its previous position by itself. So, when the body does not come back to its previous position, then the equilibrium will be known as unstable equilibrium. In stable equilibrium, the center of gravity was at lowest position, and when I tilt the body, its center of gravity rises. But in unstable equilibrium, it is opposite. In unstable equilibrium, the center of gravity is at the highest point. And when I tilt the body, the center of gravity is lowered. So that's why we can see these are the unstable objects. In unstable equilibrium, the center of gravity is at the highest position. If I want to topple over the objects, or we can say if I want to unbalance these objects, what do we have to do? I have to lower its center of gravity. And how can I do it? I can simply slightly tilt these bodies. If I slightly tilt these bodies, its center of gravity will be lowered. Third one we have here is neutral equilibrium. Neutral means no change. So neutral equilibrium is defined as if a body is placed in such a state that if it is displaced, then neither it topples over nor does it come back to its previous position. Then such state is known as neutral equilibrium. That, or we can also define a neutral equilibrium as that if a body remains in new position when disturbed from its previous position, then it is also in a state of neutral equilibrium. Let's see an example of a ball here. When I am tilting it, or when I am applying a force on it, it will gain a new position and it will remain in that new position after being disturbed. Or we can also think about an example of a football or a ball. Let's say that we have an example of a ball. If I am applying a force on the ball, it will roll on and after some times it will stop. You can see that the ball will gain, or the ball will attains the new position, and it will not come back to its previous position by itself, or it will also not topples over. So that state of equilibrium is known as neutral equilibrium. In neutral equilibrium, the center of gravity is neither raised nor lowered, but it remains at same height. Let's say an example of a ball that is rolling. The center of gravity is at the center point. When you apply the force or when you disturb this ball, it will attain a new position, but its center of gravity will remain at the same height. So in neutral equilibrium, the height of the center of gravity does not change. These are the objects which we can say as neutral objects. This is a ball. We can take an example of a rolling ball, that when I roll the ball, it will attain a new position after being disturbed from its previous position, and it will not come back to its previous position. Then the body will be in a state of neutral equilibrium. In this, the center of gravity is at the same height irrespective to its new position. Or we can say the center of gravity is neither lowered nor raised when the body is toppled. The neutral objects just roll from one side to another. So we have discussed three sets of equilibrium: stable equilibrium, unstable, and neutral equilibrium. If the body comes back to its previous position after a slightest tilt, then it is called as stable equilibrium. If it does not come back to its previous position, then it is called as unstable equilibrium. And if it gains or it attains a new position, then it is known as neutral equilibrium. What about its center of gravity? In stable equilibrium, the center of gravity is at the lowest position. When we apply a force on it or when we slightly tilt the body, its center of gravity rises. In unstable equilibrium, the center of gravity is at the highest position. When I slightly tilt the body, its center of gravity is lowered. And in neutral equilibrium, there is no change in the height of center of gravity. Now we have three situations here. We have to find out that which one is stable, which one is unstable, and which one is neutral equilibrium. So if I am applying a force on it, or if I am slightly tilting it, the body will come back to its previous position. It will not come back to its previous position, or it will remains in new position. What will happen? Yes, this body satisfy neutral equilibrium. Whereas this picture here, if I am slightly tilting, it will come back to its previous position. So it is an example of stable equilibrium. What about this? If I am slightly tilting it, it will also come back to its previous position. Then it is also an example of stable equilibrium. But if I am tilting it more, then the boy will fall and it will satisfy unstable or neutral equilibrium's example. Now, the vehicles are made heavy at the bottom. Why does they made heavy at the bottom? They are made heavy at their bottom to lower down their center of gravity. And if the center of gravity is lower down, it means that it will gain stability. So center of gravity is directly proportional to the stability of a body. Or we can also say let's say that we are not talking about the gravity here. We are talking just about the mass here. So the center of mass is also directly proportional to the stability of a body. that if we want to make the body stable, the center of mass must also be kept as low as possible. For this reason, the racing cars are made heavy at the bottom and their height is kept to be minimum to lower down their center of gravity. So these were the states of equilibrium. Now your assignment is to solve these questions on your notebooks. That's all for today. Hope you stay safe and stay healthy. Allah Hafiz.